Most enterprise data isn't in databases. It's scattered across PDFs of all kinds, reports, chat logs, email, etc. In order to be useful, AI needs access to all of that information too. Here's how HipAI solves that problem. In this example, we're using the MultihopRAG dataset, which was designed to test the ability of large language models to integrate information across scattered documents in order to answer questions correctly. HipAI parses the dataset of about 600 news articles and creates a context layer and vector embeddings at the same time. No manual data prep of any kind is required. We can see the context graph being built gradually as HipAI parses the documents. Note that this is slowed down for demonstration purposes, and in actuality goes much faster. We first get some articles from TechCrunch about OpenAI and Sam Altman in the context graph, and then next we see nodes for characters in the Marvel Cinematic Universe because of an article from Polygon about Spider-Man and Thanksgiving. In about an hour, the graph will have around 15,000 nodes and about as many edges. That will look something like this. Now when we ask an LLM a question, the model first uses the context graph to direct its search to find the right information to answer the question. It only accesses the raw underlying data as a final step right before answering it. Every answer is automatically then grounded in an explicit node source, so the system can cite exactly where the answer to any question came from. This particular example is actually a trick question because the correct response is that the 600 articles do not provide adequate information to answer the question, which HipAI does handle correctly. This is why we achieve 82% on the benchmark of about 2,500 questions, higher than any publicized result we can find. In our last video, we showed the creation of context graphs out of structured databases, and in this one, unstructured documents. In our next video, we'll show you how HipAI extracts entities across both types of data simultaneously, creating a unified context layer across all the data automatically.